Today we will discuss derivation of Maxwell's speed distribution law. Now, why derivation of a law is needed and how it is done? Actually, a law is a statement of happening of a natural process or natural event, and therefore it must completely and reliably express that process. And therefore, it is necessary to prove it. And how it is done is, it is done by proving that it is in accordance with any other already existing, well established law in this regards. So, Maxwell's speed distribution law is derived by proving that it is in accordance with the already existing theory or law named as Maxwell-Boltzmann's law, Maxwell-Boltzmann theory. Actually, Maxwell-Boltzmann theory is for finding how many number of gas molecules are present in a gas which have a particular speed or a particular velocity. How many number of molecules are present? And this group of molecules which have a particular velocity or particular speed is called cell of molecules. All these molecules in a given cell need not to be present in a particular region, particular position region or particular position space. These are actually scattered all around in the whole volume of the gas. And but one thing is there, that these molecules have a particular speed. So their speed position, speed point or velocity point is same. Therefore, instead of taking the position space, we will have to consider the velocity space. इसका मतलब हम क्या फाइंड आउट करना चाहते हैं? उन मॉलिक्यूल्स की संख्या जिनकी पर्टिकुलर स्पीड है या पर्टिकुलर वेलोसिटी है, तो एक पर्टिकुलर वेलोसिटी के मॉलिक्यूल्स और इस कलेक्शन को आप सेल कहते हैं. इसका मतलब एक गिवन सेल की कितनी वेलोसिटी है या कितनी स्पीड है. So each cell in a gas is characterized by a particular velocity or a particular speed, and we are interested in finding how many number of molecules are present there in that region of velocity. This is not the region of position. So this is simply a density or velocity density. This is simply a density कि एक पर्टिकुलर वेलोसिटी रीजन में कितने नंबर ऑफ मॉलिक्यूल्स हैं. किसी सेल, सपोज ith सेल में कितने नंबर ऑफ मॉलिक्यूल्स हैं. So this is actually the density of molecules, velocity wise density of molecules. और डेंसिटी अगर निकालनी है वेलोसिटी वाइज तो वी कंसिडर ए वेलोसिटी स्पेस instead of taking the position space. Like the position space is governed by a position reference frame, which is a combination of three mutually perpendicular position axes x, y, z. Similarly, here we will be considering a velocity space which is governed by a velocity reference frame, which is combination of three mutually perpendicular velocity axes like this. So a very explanatory and very beautiful diagram has been made. So we consider a velocity space which is governed by three mutually perpendicular velocity axes. One is say Vx, the other is Vy, and third is here Vz. These are the velocity axis and this is therefore a velocity reference frame. In this velocity reference frame, जैसे आप पोजीशन रेफरेंस फ्रेम में किसी पॉइंट की पोजीशन बताने के लिए एक पॉइंट लेते हैं एंड इट इज रिप्रेजेंटेड बाय ए वेक्टर drawn from the origin of reference frame to that point, and that vector is called position vector from origin to that point. Similarly, if you find the position, if you find the velocity of a point, then it will be represented by again a vector drawn from the origin to that point. वेलोसिटी स्पेस के अंदर हर एक पॉइंट जो है वो क्या बताएगा, वेलोसिटी बताएगा. हर एक पॉइंट एक वेलोसिटी बताएगा. जैसे यहाँ पर पॉइंट ए है, दिस रिप्रेजेंट्स ए वेलोसिटी and the velocity at this point is given by a vector which is an arrow drawn from the origin to this point A, and this vector is called velocity vector. Now consider ith cell in a ith cell of molecules in a gas, and this cell contains ni number of molecules, and each of these molecules has same velocity and same speed, suppose same velocity, say OA, same velocity OA represented by the point A and the vector OA run from the origin to that point equal to the vector V equal to Vxi plus Vyj plus Vzk, where Vx, Vy, Vz are the components of V in all the three mutually perpendicular axes. And the magnitude of this velocity in its own direction, that is in direction of OA, is equal to Vx square plus Vy square plus Vz square root equal to C. This is the velocity, this speed of each of Ni molecule, or this speed, or we can say it is the speed of N and this ith cell. Speed is actually the magnitude of maximum velocity. The magnitude of the velocity in which its magnitude is maximum. This is speed. You must understand that speed of a particle is the magnitude of its velocity in the direction in which it is having maximum magnitude. Alright. Now, the velocity V is such that, velocity V here is such that it is inclined at angle theta with z axis, suppose, and therefore its component along with z axis must be c cos theta, and therefore its component in the horizontal plane Vx Vy should be क्या होना चाहिए? It must be perpendicular to V cos theta, sorry C cos theta, इसके perpendicular होना चाहिए. तो क्या बन जाएगा? It must be C sin theta. It is given by the vector ON. This is the projection of C on Vx Vy plane. Alright, this is actually the visual part of C along perpendicular direction. Okay, sine component. And this component of C, that is C sin theta, makes angle phi with Vx axis. This is how this vector V has been taken. And these two angles give the complete information about the direction of the vector OA equal to V vector. And different values of theta and phi, by taking all values of theta and phi, we can, or this vector OA can sweep the whole volume, velocity volume in this reference frame or velocity space. For example, if you want to say take the whole volume, velocity volume, then C has to be rotated. C has to be rotated. फर्स्ट सी को कैसे रोटेट करेंगे या ओ ए को कैसे रोटेट करेंगे? फर्स्ट ओ ए और सी इज एक्चुअली द मैग्नीट्यूड ऑफ वी इन इट्स ओन डायरेक्शन, इन इट्स maximum direction, maximum magnitude direction. So C remains constant, suppose. That means in every rotation or at every value of theta and phi, the value of C remains constant. means OA remains constant. Its direction will change depending on the value of theta and phi. Now, first rotate the vector OA in horizontal plane. Horizontal plane. And therefore, theta will remain constant in this situation. Theta will remain constant. And OA is rotated about VZ axis. VZ एक्सिस के अबाउट वो घूमता है. VZ जो है वो एक्सिस होगा इस रोटेशन का. तो क्या बन जाएगा? इट विल फॉर्म है, OA विल फॉर्म है कौन. तो ये घूमेगा तो कौन बन जाएगा. थीटा अगर सेम रहता है तो कौन बनेगा जिसका वर्टेक्स कहाँ पे होगा. इट मस्ट बी एट द ओरिजिन. और एक सर्कल बनेगा, उसका बेस एक सर्कल बन जाएगा. जैसे ए पॉइंट जो है वो एक सर्कल में घूमेगा अबाउट द एक्सिस VZ एज द एक्सिस ऑफ रोटेशन. और इसलिए इसका जो प्रोजेक्शन है C साइन थीटा, C का जो प्रोजेक्शन C साइन थीटा VX VY प्लेन, this will also rotate in the horizontal circle. It will be a circle because C is constant. We have taken C speed as constant, particular speed के ही जो मॉलिक्यूल्स हमने लिए हैं. Therefore, C sin theta will rotate or sweep from the angle phi equal to 0 when C sin theta is along Vx axis to clockwise घूमेगा to the axis Vy when it makes angle phi equal to 90 degree, and then towards minus Vx, and then towards minus Vy, and then back to Vx. And therefore phi will change from 0 to pi, 2 pi, 0 to 2 pi. Theta remains constant. So this will form a circle. Again, this is only in plane. Now to sweep the volume, we will have to change the value of theta also. That means this circle has to be taken upwards, that is normal to it along Vz direction, and also downwards towards minus Vz direction. That means by taking Vz direction में कैसे जाएगा? By taking theta equal to 0. तो थीटा की वैल्यू 0 हो जाएगी. C कहाँ पे हो जाएगा? C will be, OA will be along Vz direction, and then theta is increased from 0 towards Vx Vy plane. तो थीटा बढ़ता जाएगा और इस तरह से प्लेन जो है वो जो सर्कल जो है पॉइंट जो है दैट विल बी एक्सपेंडिंग इनटू ए स्फीयर. सेमी स्फीयर होता जाएगा पहले, और जब C जो है OA विल बी ऑन द Vx Vy प्लेन, पूरा C वहीं पे आ जाएगा, तो इट विल बी थीटा विल इक्वल टू 90 डिग्री. तो हेमी स्फीयर बन जाएगा और फिर थीटा और बढ़ेगा एंड C विल बी थीटा 180 हो जाएगा, तो C विल बी अलॉन्ग माइनस Vz डायरेक्शन, और ये पूरा स्फीयर कंप्लीट हो जाएगा. So to sweep whole volume, the value of phi will be changing from 0 to 2 pi, and the value of theta should change from 0 to pi. And if C is kept constant, then it will be a perfect sphere with center at O. So this is. And at the surface of this sphere, that means for same value of C, all the Ni molecules will have same speed equal to C. This is the consideration. Now this has been written here. यहाँ पे सारा कुछ लिखा हुआ है. Consider ith cell of Ni gas molecules in velocity space of velocity coordinates Vx, Vy, Vz, in which each of Ni molecule has velocity equal to OA equal to V equal to Vx plus Vyj plus Vz. इसका मैग्नीट्यूड ये है Vx plus Vy plus Vz के रूट और इक्वल टू C or where, such that V is at spherical coordinates. These theta and phi are called spherical coordinates. तो C की डायरेक्शन यहाँ पे बता रखी है या V की डायरेक्शन यहाँ पे बता रखी है कि it is such that it is at spherical coordinate theta with Vz axis and its projection OM equal to C sin theta is at spherical coordinate phi with Vx axis. So this is clearly written here. Alright, we have considered इस तरह से Ni number of molecules. Okay. Now if let us consider a very small range in C, very small range dC in C, beyond C, C से ऊपर एक थोड़ी सी स्पीड रेंज dC और लेने, which is infinitely small, approaching to 0, and this range in dC and corresponding range in V is dV. dC चेंज होता है स्पीड, तो corresponding range in velocity will be dV, and corresponding range in the components of dV will be dVx, जो कि यहाँ पे AB लाइन के द्वारा दिखा रखी है, AB. dVy is along AD and dVz is along AE. These are very small ranges in speed and velocity, and therefore the corresponding change in phi will be, जब A से D पे जाएंगे आप, A से D पे जब OA जो है वो OD बनेगा, थोड़ी सी चेंज इन Y होगी VY, तो उसका प्रोजेक्शन जो है C का प्रोजेक्शन OM से क्या बन जाएगा, यहाँ पे दिखाई दे रहा है, इसका प्रोजेक्शन साफ दिख रहा है. यहाँ से D से परपेंडिकुलर ड्रॉ कर रखा है VX VY प्लेन पे, तो विच इज DN and foot of the perpendicular. तो projection OM will become ON, and therefore the projection C sin theta has been rotated through a very small spherical angle, it is d phi. So corresponding change in the and phi will be d phi during the variation dy, and corresponding change in theta will be d theta during the variation dvz in vz. During these variation, suppose the value in number of molecule remains same. The number of molecules remain same at each speed during this range, this variation, at each speed from C to C plus dC. This means the number of molecule at C is also equal to Ni, and number of molecule at each speed in the range dC or dV or dVx, dVy, dVz or d phi, d theta will be same. And therefore, we can say that the number of molecules in at each point, velocity point, in this small velocity space element, in this velocity space element, A, B, C, D, E, F, G, H, the number of molecules remain same at each point as Ni. नंबर डेंसिटी, इसका मतलब ये हुआ कि इसके हर एक पॉइंट पे नंबर डेंसिटी Ni रखती है, बिकॉज DC is taken as very small. This has been written here. यहाँ पे साफ लिख रहा है, लिख रखा है यहाँ पर. Let DC equal to dV equal to AB mode is infinitely small velocity range beyond C or V, and hence having resolved parts dVx equal to AB, dVy equal to AD, and dVz equal to AE beyond Vx, Vy, Vz respectively, and as such d theta and d phi be the respective infinitely small change in theta and phi during which, and hence in the velocity space region A, B, C, D, E, H, E, F, G, H, the number of molecules Ni remain same at each point in this velocity space element. इसका मतलब क्या हुआ, डेंसिटी यहाँ पर Ni की सेम रहती है. तो इसका मतलब what is the total number of molecules in this whole velocity volume, density is Ni, क्या हो जाएंगे, it will be equal to Ni into the velocity volume of this velocity space element. Now, what is the volume of this velocity space element? Volume is equal to dvx into dy into dvz, और dvx, dvy, dvz की वैल्यू आप निकाल लें. Now, from this diagram, we have taken dc or dv in the same direction as dvx. dc is in same direction. This means dc, the line dc has angle 0 with respect to dvx, and therefore dvx must be dc cos 0. Cos 0 is 1, therefore dvx is equal to dc. Number 2, dvy. dvy is ad or eh here. This has been shown as eh. dvy is equal to eh, which is ad. It is actually equal to mn. जो नीचे दिखा रखा है mn है, and this mn is actually the arc of radius c sin theta when it sweeps through angle d phi. तो mn की वैल्यू क्या हो जाएगी, radius into the angle, this is c sin theta into d phi. So this has been written here, dvy is equal to dvy is equal to c sin theta into d phi. Now eh, that is dvz equal to ae, dvz is equal to ae. ae is again an arc of radius c when it sweeps through angle d theta. तो डी वी जेड क्या हो जाएगा, इट इज रेडियस इंटू एंगल, रेडियस इज सी एंड एंगल इज डी थीटा, सी इंटू डी थीटा. So these are the values, and therefore the edges are dvx equal to dc, dvy is equal to c sin theta d phi, and dvz is equal to c d theta, and therefore volume will be equal to the product of all these three, dvx, dvy, dvz equal to dc into c sin theta d phi c d theta, और ये क्या बन जाएगा, it is c square d dc into sin theta d theta into d phi. These are the values. So this is the volume in which the number of molecules remain same. All right. Therefore, if we put this value in the Maxwell-Boltzmann theory, जिसके अनुसार the number of molecules in a very small range dvx, dy, dvz or dc equal to ni dvx, dy, dvz, ni से मल्टीप्लाई कर देते हैं, इक्वल टू n सी dc is equal to n into m by 2 pi k t raised to power 3 by 2 into e raised to power minus beta m vx square plus vy square plus vz square by 2 into dvx, dy, dvz over the whole volume, whole position volume, by taking all possible values of theta and phi, all possible values of theta and phi. Theta changes from 0 to pi, phi from 0 to 2 pi. Okay, but the value of the c is speed. It is independent of, its value is independent of direction. That is, the value of c is constant whatever be the value of theta and phi, and therefore c can be taken out of the integration, and therefore we get this. If we put this value and then integrate over the whole volume, we get dvx, dvy, dvz equal to, यहाँ पे ये वैल्यू रख देंगे, c square dc इंटीग्रेशन 0 to pi sin theta d theta इंटीग्रेशन 0 to 2 pi d phi. अब इंटीग्रेशन तो बहुत आसान है, ये तो आप बड़ी आसानी से कर सकते हैं, इट इज सिंपल प्रॉब्लम. साइन थीटा का माइनस कॉस थीटा हो जाएगा, और जब आप इसमें 0 से पाई बढ़ेंगे तो इसकी वैल्यू हो जाएगी, इट मस्ट बी 2, और 1 का इंटीग्रेशन 5 करेंगे तो 5 आ जाएगा, 5 की वैल्यू 0 से 2 पाई करेंगे तो इट मस्ट बी 2 पाई. तो 2 पाई इंटू 2 इज 4 पाई, एंड देयरफॉर द होल वैल्यू ऑफ दिस इंटीग्रेशन of dvx, dvy, dvz over the whole volume will be equal to 4 pi c square into dc. और ये वैल्यू अगर आप भरते हैं, ये वैल्यू लिखते हैं यहाँ पर, तो फाइनल रिजल्ट क्या आ जाएगा, एन सी डी सी इक्वल टू एन सी डी सी इक्वल टू 4 pi c square n bracket starts m by 2 pi kt bracket closes raised to power 3 by 2 into e raised to power minus mc square upon 2 kt into dc. What is this? This is Maxwell speed distribution law. This is the derivation. Therefore, now this was a method of derivation of Maxwell speed distribution law by taking the spherical coordinates, by taking AB initio, or by first definition method. तो AB initio से हमने किया है, but this could be done by an easier method also. एक थोड़ा सा easier method भी इससे भी हो सकता था, उसमें फिगर भी इतनी कॉम्प्लिकेट नहीं होती है, जिसमें C की वैल्यू हम लेंगे in the velocity space, or we will be doing by taking the formula directly. स्फीयर का डायरेक्टली फार्मूला यूज कर लेंगे, and therefore we can also do this derivation of Maxwell speed distribution law by formula method. This is the formula method. Okay, in this method, consider again a velocity space which is governed by a velocity reference frame, which is combination of three mutually perpendicular velocity axes Vx, Vy and Vz as has been shown here. Now in this velocity reference frame, consider a point P which represents a speed of the ith cell of the gas molecules, which contains ni number of molecules. And the speed is here given by the magnitude of vector OP, velocity vector OP, whose components are Vx, Vy and Vz. Suppose OP is equal to V vector और उसके components Vx, Vy, Vz हैं. Okay, its magnitude is equal to C. Now, C is speed. Its value remains constant whatever be the direction. And therefore, if I draw a sphere here by taking center at O and radius equal to C, then we get a surface, spherical surface, at every point of which the value remains same as C. सरफेस पे वैल्यू C रहेगी. एक्चुअली ये वेलोसिटी स्फीयर है. किसी सरफेस पे वैल्यू C रहने का मतलब उसकी वेलोसिटी C रहेगी. ये वेलोसिटी स्फीयर है. तो इस वेलोसिटी स्फीयर के ऊपर द वैल्यू एवरी पॉइंट रिप्रेजेंट्स ए पॉइंट C, velocity C, sorry, speed C. Therefore, we can say that at every point on the surface of this sphere, velocity sphere, the number of molecules remains same as Ni. This is the ith cell. हर एक पॉइंट पे Ni number of molecules होंगे. All right. Now, if I take a very small range dc approaching to 0 beyond C, and then again I draw another concentric sphere, velocity sphere, with center at same point O, origin O, and radius equal to C plus dc. Then in this small range dc, we get a spherical shell. This is a spherical shell, जो कि आपको ये ब्राइट स्ट्रिप, सर्कुलर स्ट्रिप दिखा रखी है. ये एक्चुअली स्फीयर है, स्फेरिकल शेल है, जिसकी थिकनेस dc है और रेडियस c है. रेडियस c प्लस dc नहीं है क्योंकि dc अप्रोचेस टू 0. And therefore, this spherical shell is such that at every point in this spherical shell, the speed remains same as c, dc approaches to 0, and therefore the number of molecules also remain as ni. तो डेफिनेशन है ith सेल की, जिसके अंदर नंबर ऑफ जिसके अंदर जो है वो प्रत्येक मॉलिक्यूल की स्पीड c रहती हो. Therefore, at every point, velocity point, in this velocity spherical shell of thickness dc, number of molecules remains same as ni. This means this is the density of number of molecules, velocity-wise density of the number of molecules. And therefore, total number of molecules in this range dc is equal to the number density, this is Ni, into the volume of this velocity volume of this velocity spherical shell. Now, what is the volume of this velocity spherical shell? It is equal to, simple, it is very simple. It must be surface area of this spherical shell into the thickness. Area into thickness. एरिया इंटू थिकनेस तभी कर सकते हैं हम यदि इसकी थिकनेस नेग्लिजिबल है, अदरवाइज नहीं कर सकते हैं। अगर डी सी को नेग्लिजिबल मानते तो डी सी स्क्वायर जो आएगा उसके वो जीरो हो जाएगा, डी सी अगर बहुत कम है तो। ऑलराइट, देयरफॉर द वॉल्यूम, वेलोसिटी वॉल्यूम ऑफ दिस स्फेरिकल शेल विल बी इक्वल टू, सरफेस एरिया कितना होता है, सी रेडियस है तो 4πc², ये यहाँ पे दिखा रखा है, और डी सी इसकी थिकनेस है तो इसका वॉल्यूम हो जाएगा 4πc² इंटू डी सी, दिस इज द वॉल्यूम। एंड देयरफॉर द नंबर ऑफ मॉलिक्यूल्स इन दिस रेंज ऑफ स्पीड, डी सी रेंज ऑफ स्पीड, विल बी इक्वल टू, कितने हो जाएंगे नंबर ऑफ मॉलिक्यूल्स, आप इसमें जो मैक्सवेल बोल्ट्जमैन एक्सप्रेशन है फॉर द नंबर ऑफ मॉलिक्यूल्स, उसमें आप वैल्यू भर दें डी वी एक्स डी वी वाई डी वी जेड की, इट इज इक्वल टू, तो यहाँ पर पूरा वॉल्यूम जो होगा इट मस्ट बी इक्वल टू 4πc² डी सी। ये वास्तव में क्या है, इट इज द इंटीग्रेशन ऑफ ऑल दीज थ्री। अगर डी सी स्मॉल रेंज ऑफ स्पीड है एंड कोरस्पॉन्डिंग स्मॉल रेंज इन वेलोसिटी इज डी वी, जो कि ओ पी को आगे बढ़ाएंगे तो डी वी आ जाएगा, ओ पी इज वेक्टर, वी वेक्टर, एंड कोरस्पॉन्डिंग चेंजेस इन द कंपोनेंट्स ऑफ डी वी आर डी वी एक्स डी वी वाई डी वी जेड। तो इसका वॉल्यूम क्या हो जाएगा in all the three directions, it must be the product of these three velocity components, velocity range components dvx dvy dvz, और फिर इनका सभी का इंटीग्रेशन ओवर द होल वॉल्यूम, सभी वैल्यूज के लिए, और दिस इज इंटीग्रेशन ओवर द होल वॉल्यूम irrespective of द पोजिशन, होल वॉल्यूम में इसका इंटीग्रेशन कर देंगे तो क्या वैल्यू आएगी, इट मस्ट बी इक्वल टू 4πc² इंटू डी सी, जो हमने ये पहले फाइंड आउट किया है। ऑलराइट, तो डी वी एक्स डी वी वाई डी वी जेड इंटीग्रेशन ऑफ दिस ओवर द होल वॉल्यूम मस्ट बी इक्वल टू 4πc² इंटू डी सी। नाउ देयरफॉर फ्रॉम द मैक्सवेल्स वेलोसिटी डिस्ट्रीब्यूशन लॉ, the number of molecules in this range of velocity components dvx dvy dvz beyond vx vy vz, that means the number of molecules ncdc in the speed range dc beyond c over the whole volume v triple integration dx dy dz irrespective of the positions, their positions, this is x y z, is क्या हो जाएगा, it must be equal to ni dvx dy dvz is equal to ncdc is equal to n into m by 2 pi kt raised to power 3 by 2 into e raised to power minus mvx square plus vy square plus vz square divided by 2 kt into dvx dy dvz। अगर सारे वॉल्यूम में लेंगे इंटीग्रेशन में तो dvx dy dvz का ओवर द होल वॉल्यूम इंटीग्रेशन क्या हो जाएगा, इट इज 4πc² इंटू डी सी, ये वैल्यू रख देंगे 4πc² इंटू डी सी, यहाँ पे जो हमने पहले निकाली थी ये वैल्यू 4πc² इंटू डी सी, तो वी डी वी एक्स डी वी वाई डी वी जेड की वैल्यू यहाँ पर रख देंगे बाई इंटीग्रेटिंग ओवर द होल वॉल्यूम, तो 4πc² डी सी, तो बड़ी एक्सप्रेशन क्या बन जाएगी, यू कैन सी हियर, एन सी डी सी इज इक्वल टू 4πc² capital N bracket starts m by 2 pi kt, bracket closes, raised to power 3 by 2 into e raised to power minus mc square upon 2 kt into dc. This is again Maxwell's speed distribution law. So this is all about the derivation of Maxwell's speed distribution law by two methods. Thank you.